and this is normal packet transformation, right? Just that basically we also need to go through, for example, the ACL layer and the LPM routing layer, right? So it's more like that there is like an ACL layer when we have different kind of groups of ACLs, right? Because customer basically can apply ACLs, for example, on a subnet, can apply ACLs on, let's say, entire subscription, can apply ACLs on the VM, right? And how the system is designed in a way that, and we also have the default ACL group for, let's say, protecting our infrastructure, right? So if, for example, because like, for example, customer may have their own address space, let's say 10/8, right? And want to go to the internet. So they, for example, go to 888 and we just leave packet out, right? Which is kind of not encrypt, this kind of stuff, right? But if customer, for example, has address space 10/8 and going to, for example, 100 dot something, right? It is not really internet address, or 192, it's not really internet address, right? So we know from configuration that customer has it basically doesn't have this address configured as their VNet, but at the same point is not, let's say, internet address. So we plump those additional spoof guard rules in one of the ACL layers, right? So the processing is relatively simple, I would say, from the point of view how we are doing data planes. That first packet basically goes, when the VM outreaches packet, it goes through multiple ACL groups. It needs to pass through all the ACL groups, right? And when it goes through ACL group, the action on this can be either allow or deny. If the ACL, and there is two types of like properties of those actions can be, for example, allow, terminating, or non-terminating. If this terminating means it is basically this group, and this rule basically says that this is basically what's happening, right? If this is not terminating, but we already found an action in this group, right? This means that we still, like, for example, even if one group says allow, right? Then we go, in this case, to the next group, and the next group may actually deny this traffic, right? This is kind of the non-terminating behavior. In a way, kind of, we still need to jump through the stuff. So this is basically what's happening with the ACL layer. So it's relatively simple. The only complexity, I would say, mostly from the hardware implementation, is that customer can specify each action, let's say allow from a number of lots of prefixes to, for example, lots of prefixes, and they can also specify that, for example, they want to allow from, let's say, those lots of prefixes from this point range to this point range to the other prefixes, right? So that's the only complexity from the point of view of the hardware implementation to kind of optimize on this.
The only hard part is that it's hard. Yeah, I got it.
Yeah, yeah, exactly.
I've implemented these kind of things before, and so I know how to do it, and I know some other people that know how to do it. So you'll find people that know how to do it, but it's not your slam dunk, throw it in a TCAM and you're done. So
that's true. Yeah,
and customer, ways to do it.
Yeah, exactly. And customer right now can use also tags. So for example, can say allow from, let's say, Azure Cloud or like storage.us to, let's say, internet, right? So they can use that kind of like tags which are being expanded right now. In the first proposal, I believe we didn't list the tags because we will be still expanding this, right? But this kind of optimization that will go later to kind of add ability to also define the tags. So if the customer add the tags, we don't need to expand them. We can basically plumb the specific tag. And basically this is this, and then after ACL layer, which is kind of those groups, it really goes to the routing layer, which is basically LPM routing.
Okay.
Right. So it goes through LPM routing, and this is fully user controlled. In a way, the customer controls we always, like, if the customer doesn't provide their own user defined route, so doesn't provide their own route table, we do plumb the route table, right? If the customer provides their own route table, we basically plumb those route table. Plus, we also add additional LPM rules if, for example, customers connected to, let's say, Express Route Gateway, like a Cisco device that connected to on-prem, let's say, or Arista or any other device basically that's connected to on-prem, and advertise routes through BGP, right? Because we have like ability that the customer can connect to on-prem, right? And we basically have on our control plane, we pull the routes from on-prem from those devices. And this is usually where the lots of prefixes are coming. So that's why, for example, the requirement is to have, for example, 10K or 100K prefixes, because usually the customer defined route table is really usually small. Most of the routes are actually coming from BGP, which basically we merge, and we actually don't update them very often. So usually, even if the BGP updates very often, we actually have agreement, at least on our side, with team who is doing the routing, that they will not send us update more often than every 30 seconds. So it's not very often that we are programming, right? But we also have this kind of agreement with them that even though they will not send us update every 30 seconds, we'll still be pulling very often. So we are still pulling them, let's say, every 5 seconds or every few seconds to kind of react very fast on the change. But once they send us, the next update can be only after 30 seconds, those kind of stuff, right? So this basically creates a route table. And I would say route table is normal route table. The complexity later starts with those specific action that if, for example, someone says that address, let's say 10/8 is my on VIN address space, right? Because we have underlay and overlay, right? In overlay, 10/8 is the VIN address space, right? But underlay, for example, if the overlay address is 10.005 versus 10.006, right? They may be on completely different location in the data center, on completely different physical nodes, right? So it's so basically, even though you hit this rule, route target, let's say VNet, this is basically the route rule. Let's say the 10/8 is a VNet, right? Then depending on the destination, the actual destination that you are doing, so the LPM already won. So basically it won that this is for example, the route rule, which is the VNet, right? But then depending on the actual destination of the 10 dot something address, right? There is a lookup table that basically based on the actual overlay address, which is 10.8, for example, specify that 10.8 is actually on this specific physical machine, and this should be the outer end cap, for example, that should be plumb, right? And we also enforce MAC addresses, so the lookup table has also information that plumb the specific MAC address as the outer destination, not the outer destination, but like inside. So basically, it overrides the MAC address, right? And use the key based on the lookup, right? Or based on the route rule in this case to kind of encap with outer VXLAN and just send the packet out. And when the packet comes in, it basically does the decap based on the GR key, so no longer the LPM table, right? And then goes through the ACL layers just in the inbound direction, not outbound direction. So that's mostly what the VNet traffic is.
Hey, Michael, all the things that you have described, right? As the packet goes through ACL layer, it goes through routing layer and all of those things. This is, as we understand, is a slow path. In other words, it's perhaps for the first packet.
That's correct.
Basically, so once you have established the flow based on that, then essentially it just, subsequent packets just only going to take the flow table, right?
Yes.
So now the question here is that those first packets that we are talking about, that are going through all of this, ACL layer, the routing layer, and so forth. Those are the ones. These are essentially those, first and the last one, right? The AG or SYN. Sorry.
Yes. Yeah, exactly. So, and this is the packets that we need optimization on, right? So for example, we already full hardware optimized for the flows which are offloaded, right? So these are like FPGAs dedicated to this kind of stuff, which are very simple. Like in a way, for example, we because we have VFP, which is doing the slow path processing in the CPU, right? And then once it figure out what is the final transposition, it just offloads it to the hardware. So this is the part that is already fully optimized. What we are right now asking as per the dash, right, is to optimize the slow path in hardware, because we tried a lot in software, right? We even have like beefy machines, this kind of stuff, in CPU, this kind of stuff, right? But this is where the CPS, so connection per second, so there's like SYNs, this kind of stuff, right? We're coming into picture, because like if there is already existing flow, then it's very, very fast, right? And we don't have any problems with this. The problem is really with this processing of those rules, doing the matching, because we tried on software, we couldn't reach the CPS.
Okay. So you want a better price performance for first packets of flow.
Exactly.
You get with the x86 or ARM core.
That's correct.
Yep, makes sense.
That's correct. So that's the main goal of the basically CPS, right? Because it's about optimizing connection per second, not so much bandwidth and the throughput in this case.
Right. And then about the flow table, do you have the example of the flow table in terms of, how it looks like and how large the flow table entries are?
So the flow table has 5 tuple match. So it will basically have a source IP, destination IP, source port, destination port, and the protocol, right? And then it will have information about the basically transposition. So the final transposition, whatever rule got hit, right? It's there. So for example, if it should basically add outer end cap, it will have this information, and it's like VXLAN ID like VXLAN key, it will have this, right? However, from this point of view, so there are different vendors, not vendors, like basically, like even internally, right? We have different implementations, which sometimes, for example, sometimes for tracking metadata, they are, for example, adding some more bits in the flow table, right? So flow table, as long as it has basically can correctly match the packet and can do final transposition, right? Plus there is the stuff that in the flow table we also are listing the specific bucket counter, because we call it metering bucket. It's basically a counter. So usually when the packet gets hit, I'm not quite sure if this we already described or not, but this can be like once we have once we have the final stuff that for example does the packet processing and do this, right, then basically metering, I think it's there kind of on the scrap. It's basically like whenever, for example, some route type gets hit, right, and we hit the route target VNet, that goes to the VNet, right, and then based on the mapping, right, each mapping apart from the, let's say this is the underlay IP, this kind of stuff, will have also an ID of the counter of the metering bucket, and we'll create basically those counter pre-programming before, and then we'll reference those counter in the mappings. And then, for example, when the flow gets created, then the flow lists basically those this basically counter ID, and when the packet goes in or goes out through the specific flow, right, then the specific counter should be incremented, and it should be tracked separately for the inbound and outbound, right? So basically we are tracking separately inbound and outbound. So if we reference, for example, some counter, let's say number 5, right, then when the packet goes out, the number of bytes gets incremented to this counter. When the packet comes in on the same flow, number of bytes gets incremented for the counter. So this is basically the metering. So it's more about basically on which thing we assign the counter. And right now, there is 2 ways to assign the counter. So the counter can be assigned either on the entire route rule, which says that whatever basically packets it's going, as long as it hits this route LPM rule based on the LPM, right? This is always the counter, always is the same counter, right? And most of the scenarios, like for example, you are going to the VNet traffic, they have common counter. If you are going to, let's say, through to, for example, the let's say VNet peering, they have basically common counter for the VNet peering, right? However, there is some subset of the scenarios, like for example, here we have like a private link TBD, because kind of next step, where some of the IPs inside the basically VNet address space, right, can be marked by the customer. This is like private link IP, slightly different transposition, right? This is kind of like a TBD, yet, but it's like slightly different transposition. In this case, you can assign. You should also be able to assign the counter on the specific mapping. So in this case, if the counter is on the mapping, this will take precedence. If there is no counter on the mapping, or there's basically number 0 there, then basically the routing should take precedence, right? But at the same way, I don't want to diverge this kind of like the next step, right? The first step that we really would like to have is basically this VNet to VNet communication, right? And you guys can start thinking about basically how to add metering, because at some point we also need to add metering. And I believe if this is not yet updated, we will be updating this soon, kind of those additional details of the metering.
Yeah, I think this is a extremely important topic. And I also wanted to have this one as part of the agenda this week, if we have the time to talk about some of these, statistics and metering and so forth. Because again, the idea here is that, we are talking about per flow statistics. We are talking about like 50 million flows. We are talking about, these in-out byte as well as packet statistics. And also, depending upon, the type of flow it is, it could have, different, like as you mentioned, in terms of, this private link part, right? The mapping metering as well. So all in all, probably we need a much more, I guess, detailed documentation on the counters, meterings, and statistics and so forth for this particular, project. That's what my view is, because there are a lot of questions. In fact, at least I have a lot of questions in that area, and our team also has a lot of questions. So I think if we have time, later on, after we have this discussion, I'd like to bring those questions up, and then we can probably see if we can carry out the discussion. We may not be able to complete the discussion in this meeting, but we can, on an ongoing basis, we can try to see if we can answer those questions.
Sounds good.
Yeah.
Yeah, and just as a side comment, this is really good to get the insights, Michael, and I think it's really valuable to capture the gist of all of this in writing somehow, because we're having a lot of oral presentations that are really teaching the community some of the the inner details, but if we don't capture them in writing, it'll just be lost in a meeting somewhere, right? And whatever we remember. So if we can somehow get the essence of these discussions into the documents, it'd be really valuable.
Yeah, definitely. Because I remember when we kind of originally started, we also have some internal meetings when we kind of were doing the kind of presentation. Because the interesting stuff about the SDN in general, how it started in Azure, right? That it started many years ago, and in a way, like customer needs VNet traffic. Okay, then we added VNet traffic, right? Then customer needs this kind of stuff. So there is lots of, for example, some documents here, this kind of stuff, right? So part of, right, like it was never one big common document on which basically people were contributing. So this is right now what we are doing right now as part of this effort to kind of not only aggregate it in the common document, because we don't have one common document even in Microsoft, right? Because it was, everything was kind of feature-based. That was kind of being added, right? And part of this, we have it like here and there, and part of this basically right now we are aggregating this as a common document, and in addition we also kind of publish this for the external community. So this is basically what we are doing, right? And we already have, for example, the information about how the private link is done, right? Even though externally is like TBD, right? And I believe that the main reason why, for example, this was not yet published is that we are still waiting for the SAI implementation to kind of propose it, and we were thinking about basically doing this together, right? In a way that, hey, this is basically the SAI proposal, how does it work, and this is how it works with the private link, right? And yeah, but this is private link is more like some specific type of the transform, right? Once we get the, but for us, it's kind of like, sure, some customers are using private link, increasing in number, yes, but at the same point, everyone is using VNet, right? So the VNet and being able to kind of meter on the VNet, that's important part.
But there's one question I want to ask. Isn't this in reality going to be formally specified in the P4 model? Because this table, this flow table, need to appear in the P4 model. Correct? So
I didn't fully understand the question, to be honest, about.
I mean, we basically said that on GitHub there is a P4 model which we need to comply with. Okay, aren't this table, for example, the flow table, the counter, etc., part of that P4 model? And if we comply with that P4 model, then we are fine.
Marian says that model is incomplete, so it might not be.
Okay, but we need to fix it. What I'm basically saying here, what scares me about this project is that we cannot comply with 20 different documents, because it's never going to comply with 20 different things. Because with 20 different things will be partially contradicting each other. For example, the flow document today partially contradicts the P4 model. So we need to reconcile them. One needs to be primary.
That's correct. Everything should be reconciled, and that's why the GitHub, right? When we should basically be kind of updating, contributing, right? Because I know that, for example, there was also a question about the fragmentation that came later, right? That originally was not published, right? And whenever we have answer, basically this will be additional document that will be kind of being updated as per the fragmentation or the main document updated. So everything should be in sync, right? If something is basically out of, so I understand that Christina right now is showing that there is an answer, right? But apart from the answer, we'll be always linking to a doc when we'll explain more about this. So there'll be one source of truth, right? So there'll be that basically, let's say, right now it's like quick answer, right? But there will be basically that the answer will link the document, and that there will be one source of truth, right? And if you guys will notice, like Silvana, you notice that, for example, something that is not in sync, right? Let's communicate it, right? And let's try to, in this case, resolve the where's the problem, right? And we basically say, okay, no, this is basically, and the other document have something maybe slightly out of sync or incorrect kind of stuff. So because definitely we should have one source.
That's perfect.
I agree.
But Michael, can we agree now that the golden reference model is the P4 code? That the document is a good introduction to the P4 code, but when there are differences between the document and the P4 code, with P4 code is authoritative. Because if we don't do that, then we will never be able to simulate, we will never be able to test it, we will never be able to, because we cannot test against the document.
Yeah, that's true. So the only thing that basically comes to my mind, right, is that engineers who are working on the P4, like it's basically like once we release some update on the document, right, it will probably take them some time to update the P4 model. So that's the stuff, but definitely the goal is to have the P4 model to beat the model, right? So that's definitely the goal, right? I'm just saying it may be slightly lagging.
Okay, that's fine. And I have another question related to this, which is always about compliance. Somebody in the other meeting mentioned high availability. So I need to understand the compliance with high availability, because again, if high availability is in the P4 code, that's fine. I comply with the P4 code and I'm done. Okay. If high availability is outside in the controller, that's fine. It's not a problem of the smart. But if I need to do something else, where is that something else? Is it a new piece of Sonic? Is it somewhere else? Where is it?
So the high availability. So like the view of the high availability is like this, because at the moment when if the cards is inside actual physical host, right, then we know that the host has basically one card, and basically if the host dies or the card dies, the entire host is not reusable, right? But if the card is basically there, or in this like intelligence switch that is there and serving more than one customer, right, it is actually acting as is kind of similar as a Tor, right? And there is a slight difference between Dash versus Tor, in a way that Tor usually doesn't keep any state, from the point of view that, like, if the packet lands on one Tor or the other Tor using ECMP, it's basically land and goes there, right? From the point of view of the Dash, because the transposition happens, right? It will create the flows, right? So the flow will be established. So in this case, the stuff with regards to here is that usually, and this is what we are also doing with Maxes, for that they are basically doing the multiplexing of basically traffic, which is, for example, coming from external balancers, this kind of stuff, right? Is that we usually have a set of maxes, this kind of stuff, and packet can land on any of them, right? And they are, for example, they are working in a way that they are bouncing the packet. So, for example, the packet goes to the one device, right? And this device doesn't create a flow instantly and send out. This device basically will first send the packet so we'll came up with a transposition, yes, because we want to have one source of truth. So we'll came up with a transposition, and based on this transposition, we'll send the copy of this packet with the metadata, because we cannot cache anything, right? Because it's kind of like almost line range, because we want about the CPS, right? We'll send this to the backup device, the second one, to kind of, hey, this is the packet and this is the flow that I created, persisted, right? And then this device basically will send it back, right? And then the bounce packet out. So this provides capability. At least this is what you are doing from the point of view of the load balancing, right? For the more advanced scenarios, you can similar like that scenario for kind of like a stateful NAT, and the NAT that customer can control, which kind of release as the managed NAT, where basically packet lands on one of those devices, and it needs to be fast, right? So basically it bounces to the second device with the metadata of what kind of decisions were taken, right? In this case here, this is basically, let's say, final packet transposition plus potential metadata, send it back and send it out, right? So this is basically how we are right now handling HA, and I would say that most likely this is how we should be implementing this, right? Unless, because like you guys are very smart, right? Because like we have like right now in the community people from all over the place, right? Different companies, this kind of stuff, right? So if you guys think that there is a better model to kind of provide this kind of like flow consistency, because the idea is like if one of those devices, like if the Tor dies, the other Tor picks up because it's completely stateless, right? Here there's a state which is the flow, right? So if the one card dies, right, the other card will start receiving traffic for the already established connection from the customer perspective, right? So from the HA perspective, right, it is okay from the point of view that if the card dies, right, then there'll be some few retransmissions, right? But the connection should not be dropped, right? So the few retransmission, because the packet that dies need to convert this kind of stuff, it's fine. But the packet should not be dropped because, for example, we don't have flow, which was already established on the previous device, right? So that's the main thing, right?
But what you have described seems it should go in the P4 model.
P4 code describes packet processing behavior only.
Yes.
99% of the system will be control plane software running on general purpose CPU, not written in P4. If anybody tells you anything different, I think they're fooling you.
I didn't say the P4 code. I said the P4 model.
I agree with Silvano. I think that the HA, like at least for the state synchronization, that can happen on per packet basis. There's state changes to the flow table, and there needs to be something in the P4 code. It might just be like some kind of call to an external function, and we could define what that external function is. But whenever there's a state change that's like reflected from the data path, it has to be communicated to the HA partner. I agree. I think it needs to be in the P4 code. I mean, it doesn't have to be P4. It just has to be some external call from P4 to say synchronize this flow.
That begs the question, is that going to be a standard mechanism? Because then you could have two different vendors' cards interoperate and sync their flows.
Right. And I think
that would be nirvana, right?
I think we need to define what that synchronization event is and what the protocol is. And this is something that we've been working on, and at some point we'll maybe share that. But I think it definitely is a function of the data plane to at least initiate like state updates from one data plane to its partner's data plane.
Yeah,
and
so right now
an additional part of control plane, and we want to standardize that, we will need some pseudocode for that control plane.
yes,
And I don't know where that is going to run.
Yeah, so what to did, we were definitely thinking about standardizing control plane APIs from the point of view that to be able to standardize APIs saying, hey, add the replication partner, remove the replication partner, get the status of the replication to know if this is healthy, this kind of stuff, right? Then you were thinking about standardizing. However, right now, we were not thinking about enforcing standard of how exactly the replication between devices should go and how the package should look there. But I'm open, like if the entire community wants to basically say that we should standardize even those kind of stuff, right? Then we can, right? But right now we were more thinking about standard because, like, for me, basically, how two devices communicate the state between each other, because it's also like what exactly they are keeping in the flow tables and those kind of stuff, right? This definitely we can standardize, or it can be device internal, right? The one thing that I want to definitely standardize on is what kind of packet transposition we want to support. So from the point of view, like what's the stuff that what we can do with those packets from the point of view of the software-defined networking, right? But the stuff that, for example, how exactly the flow table is optimized, not optimized, those kind of stuff, right? We can definitely and how those are being synced, right? That can be. We can definitely standardize, right? Or we can open this for internal event implementation. I'm open for both of those, right?
Michael, just one quick question. So in the in earlier discussions that we had during the meeting, when we had discussion about an appliance or a smart switch, which contains multiple DPU cards,
yes,
the discussion was that it could be a mix and match. It may not be from all the DPUs, may not be from the same vendor, right? Depending upon, there was a discussion about you could replace them depending upon, if one were to die and so forth, right? So it could be, so they're hard replaceable ones. So the idea here is that if they are dash compliant DPUs and they are from different vendors, there has to be a, some standard way of defining that when the flows are replicated, and if the flows have these metadata, which essentially are going to tell from active to passive or from primary to secondary cards, we need some standard of this communication that this is, and then on those then we have interoperability between multiple different DPUs, right?
So to be honest, like I need to talk with Gerald on our side, right? I'm not quite sure if how strong is this requirement that if there is a switch from the cards, that it should be able to interoperate from the point of view of the synchronization stuff with the basic cards from different vendors. I'm not quite sure. I need to check basically if there is some requirement.
I think that there are two cases. I think there's a failover case, and I think it's perfectly reasonable to say for the purposes of failover, there'll always be two like cards, and you can have a proprietary protocol and synchronization between those two cards. From the perspective of, I'll call it live migration, which is not a failover, but you just want to basically take an operating card and move the flow table to a new card. Potentially that could be vendor to vendor, but that doesn't have like the same requirements as like a failover where you
that's
have
correct.
to. Right. So like I think that there's kind of like two HA cases here. One which is failover, and the synchronization required for failover is really like the data planes have to be communicating with each other. But for live migration, where it's like, where it's like a planned operation to move all the flows off of one card to another card, like that could be done in a
standardized way.
A standardized way, right?
My recommendation would be for phase one to just have the GNMI code to say which is the failover partner, and say that the transfer is proprietary between two cards, between two identical cards. Because it seems to me that for phase one, we have already a lot of things on our plate. Also standardizing the transfer of data between different flow tables. We can always add that in a later phase.
Yeah,
that would be my recommendation.
We shouldn't mandate total interoperability in flow state synchronization if it has the, let's say, negative impact of getting the least common denominator approach. It might prevent innovative approaches from being 10 times superior, for example. So we don't want to shoot ourselves in the foot and say it must be the lowest common denominator technique. Someone may come up with something that blows the doors off of everyone else, and we should welcome that, right? Innovation.
Exactly. So this is why kind of like P4 pipeline is kind of like people who have how this process, right? But how, for example, later the memory with the mapping is being stored, this kind of stuff, right? We don't want to also enforce it, right? So for example, if one vendor want to optimize the memory in this way, the other vendor want to optimize the memory in the other way, the other vendor doesn't want to optimize memory to, for example, give higher CPS, right? We just want to standardize on actually what should be how the processing of the packet should go and what kind of transposition and in which order, right? Not so much about the internals, right? How deep we'll go on this to standardization, right? I agree here that we definitely want to make sure that each vendor can basically have their own kind of secret sauce, right? To kind of optimize, and there is also standardization of the APIs of how we want to call it from the control plane. So this will not change, right? The standardization of what is happening with the packet, right? And then we want to also be able to provide the innovation part, which regards to we don't say how exactly it's handled internally, right? And there is open question like whether, for example, the state communication between two paired cards, right, should be proprietary or not. From my point of view, if it's not proprietary, then we can link all the cards together. Awesome. From the other point of view, right, potentially maybe some vendor has some, for example, ability to pack some stuff, and those packets can be shorter, done differently, optimize those kind of stuff. So I don't want, at least right now, to kind of limit this capability. At least this is my thought.
Thanks. Hi, Michael. Back to the basic ACL processing that you described earlier in the meeting. The scale requirement in the packet transform indicate it's 100K, and there's also a 10K source destination port. Is 100K prefix, is that per ENI, or is that for the entire DPU?
No, 100K prefixes.
Yeah.
So I can tell you that per ENI right now, we already have ACLs which are referencing to the rules, which have like, let's say 7K prefixes and this kind of stuff. This is basically definitely per ENI. We have ACLs that are referencing this, right? Because like if you specify, for example, entire, let's say Azure Cloud, right? Entire Azure Cloud, like if you say from Azure alloc traffic from my VM to Azure Cloud, right? Just the Azure Cloud prefix for the customer, right? Expands right now to, I believe, like 7K unique prefixes, right? So this we would like to be from the point of view like 7K is right now, right? So if we design right now, spend engineering effort to right now design the card that can only handle like 7K or 10K per ENI, right? Then this is kind of designing for right now, and the future in a second will be slightly bigger, right? So I would say that this is like 100K per ENI, I would say. And definitely with the tax, there will be optimization. So we'll be using lots of the optimization later with the tax. So we should kind of discuss it, but we would prefer to have 100K per ENI here, right?
Oh,
and then
okay.
also the interesting stuff here in the document, right? We specified that, for example, we want to support so many ENIs, right? And I want to clarify here that the idea of supporting so many ENIs is ability to basically program them. And we know that depending on each vendor will have its own kind of memory memory calculator to figure out how it's being used, right? Because like let's be honest, like at the end, basic cards have, let's say, for example, 200 gigs basic connectivity or 400 gigs connectivity to the Taurus, this kind of stuff, right? And we know that each customer also requires some bandwidth, right? So even if we, for example, program, let's say 1,000 ENIs on one card, let's say it's theoretically possible, right? Those customers will not be able to use the bandwidth because they will saturate themselves, right? So we'll never program so many, right? But because sometimes we are handling customers, for example, who have very tiny, let's say they are very tiny customers, which are, for example, deploying the VMs, which are, let's say, smaller, right? And for the smaller VMs, we'll say, okay, this is a smaller VM, but you have like smaller number of CPS, right? And this kind of stuff, and there will be all those kind of limits, right? Which means we can fit more of those in the card, right? So it's mostly about not constraining ourselves from the point of view ENI, right? But this 100K is mostly per ENI.
Per ENI, but then overall, I understand, depends on the deployment. The maximum number of ENI will be different. But overall, for the entire DPU, what are you looking at? Because it's not a simple multiplication of the number of ENI into 100K per ENI, right? So overall, what are we looking at? 1 million, 2 million, or I mean, what would be a reasonable number?
To be honest, it's hard for me to answer this question, right? Because
maybe we can define
for the capacity that you're having right now. What does it look like? Do you know of?
So
otherwise we
what does what look like, Lisa? I'm sorry. What are we targeting?
Yeah, so
my question is per DPU overall.
Per DPU, what's the question? This is per DPU.
What is the ACL scale? Yeah.
It's right here.
But Michael just clarified 100K is per ENI.
So but isn't it below? It says 10 million total mapping. Three line below. It says 10 million total mapping.
No, that's
total mapping is this, right? Because the scale for the ACLs, right? We are actually envisioning that we will be able to plan those as a tax, right? So.
Michael, I hope my question is clear. Christina, I hope my question
is clear. It is clear. The answer is just so I would say like this, the answer is actually very hard from my point of view because we don't have yet those kind of like the only devices that we have right now that are kind of doing this is software defined devices where we basically have basically lots of memory on those. Everything is like software processing, right? So we never kind of we don't have any yet kind of like device that is in hardware to figure out how much really we can feed in the hardware, right? If we had, we will tell you guys that right now we have a hardware that fits so many and we want basically like X more, right? But we don't know, right? So we don't know how you guys will be able to like fit
it. If you could take that as a homework item to think about it.
Okay.
Yeah, but guys,
is
it fair to say that, if you have X number of ENIs, there is basically, requirement, right? Say, for example, for a DPU, if you have a requirement of, say, 40 ENI supported, right?
Mm-hmm.
Then is it basically is it like a direct multiplication, the 40 times 100K, and essentially that becomes 4 million IP prefixes that are required to be supported?
I understand the question. will this be direct multiplication? Let's do like this. Let's take it as a homework, because
Okay.
because I know that there is lots of question about this, and I know that we prepare those kind of stuff thinking that okay, we want this because, for example, our platform has this kind of stuff, right? But let's take it as a homework to kind of discuss this. I know that like James on our side, he's awesome guy who's driving kind of like ENI placement and kind of figure out what kind of SKUs we'll be offering, how many CPUs and this kind of stuff. And this kind of drives part of the discussion, right? So we need to potentially clarify slightly more of how this
So while we are doing this homework also on the same subject, could we also find out the number of rules, right? So we're talking about IP prefixes and the number of ENIs. We also talk about, how many rules per customers there is a requirement, right? Because we talk about prefixes, we talk about ports, but we also need to talk about the ACL rules per customer as well. Okay.
So hey, this is Mel. I'm new to this forum, but a lot of this is some of this is specified in the other document, the scale requirement document, where they have the hero test. So there's this hero test, right?
Let me jump in real quick, Mel. This is James,
hey, James.
that Michael was just referring to. So yes, we do have a hero test, and the hero test outlines in worst possible conditions, some performance metrics we want you to be able to hit, and give some configurations. But there's kind of an overall question about the given capacity of what a DPU looks like, and we have some ballpark figures, but there's a lot of great questions that Michael has attempted to answer. And to a certain extent, what he's telling you is there's a little bit of a sliding scale, because things are proportional. You'll have a memory footprint that's devised by all of the things that make up an ENI, but you'll also allocate out bandwidth. So the different vectors, the CPS vector, the bandwidth vector, the memory vector, all kind of have to work together. And we have ballpark figures, but we do need to come back and give folks a little bit more clarity on what that looks like, right? And so definitely we're looking at this now, and we can come back to this forum and try and give the information in the terms that people are asking for it, right? So I think we've put some things down for now, but there needs to be more clarity, right? Have I summarized this correctly? Do folks have something they want to add on top of that?
That makes sense. I was just speaking specifically about that document, which has that there's that 8 ENI scenario and the 1 ENI scenario, and it lists out the the 48 NSGs per DPU kind of numbers. That there are some numbers there already, and you're saying that those will be clarified.
Great. One follow-up question I have regarding that document. This is the goal for Dash, or this is the current deployment that you have. How should we interpret the scaling number in this document?
So I would say the scaling number, let's go back to this, as James mentioned.
No, I mean, let's say for this document right now, right? Whatever the number that's being put here, should we interpret this is the goal that Dash going to achieve, or this is?
So Lisa, maybe I think, the, for the scaling number, right? So, it's always going to increase, right? So we have think about, we have switch, we have, 12 terabyte and, 25 terabyte, always going to increase, right? So, the hardware improves, right? So I think, in terms of scale, and also the customer's load increases. I think, this we probably wouldn't give you, okay, this is the goal, right? So, kind of that, right? So, but I would say at least, this would be the, kind of minimal bar, right? So
okay, got it.
Yeah. So
can you scroll down?
You gave me the answer. Yes. So basically, we should treat it as a minimum requirement for Dash.
Can you scroll down a little bit more?
This document is pretty good, by the way.
Here we go. This is the one. So this was eye-opening to me. This showed for 8 this is really 8 ENIs per DPU, I assume, right?
Yeah.
Which leads to this kind of like, again, it sounds like, you know, these are not necessarily maximum numbers, but this is one scenario that there's an expectation to be met.
Yeah.
It's one testing
Right.
scenario.
And
yeah.
Yes.
Yeah.
Let me give some context here as well. So 8 ENIs is not necessarily the maximum you would ever have. What we wanted to demonstrate here is that a card, one ENI could potentially be the entire capacity of a DPU, or you could have multiple if you took the same capacity of one DPU and you divided it equally amongst 8, you might see a configuration like that. And so this isn't comprehensive. It's kind of, again, it's a little bit of a sliding scale, but the purpose is showing you that like if you take the entire capacity of a card, it could be facilitated all in one ENI, or it could be divided amongst a certain number of ENIs, and that's why we split between 8 and 1. And it also gives an indication of what a stressful scenario per ENI might look like, and so, you know, maybe some people were referencing like 40 ENIs. So if you took the entire capacity of a card again and divided it amongst 40, you might see another test scenario for 40 ENIs based on the capacity of a DPU.
So I mean, I had this question, Christina, for you also. Is this correct? Because it looks like this changed in the last month or two. The 1 ENI scenario, if you notice, is exactly the same as the 8 ENI, and these numbers look wrong to me. What 1 ENI would not have 48 unique NSGs, would it? Because I thought that in the other document, in the other document there was
No, that's correct, because basically usually 1 ENI has basically we
3 inbound and 3
wanted to have
outbound.
like five different kind of like NSGs from the point of view of 5 different groups, right? So that's correct.
Wait, what do you mean 5 NSGs?
Well, here's like 8 multiple by
so this
6,
8 times
yeah,
6.
so 6 NSG, yeah, it has 6 NSGs, yeah.
Right. So to me, this 1 ENI scenario looks incorrect.
Yeah.
It looks like it
let
should.
me
Yeah.
check it while we're talking.
Sorry.
Let me double check it while we're talking.
Okay.
Yeah, I think it's I mean, definitely I can tell you guys that we definitely don't have this kind of configuration right now.
Right.
and this number of basically there like LPM prefixes, this kind of stuff, this looks
but yeah, guys, one other thing that I see in the documents is that, you know, but I don't see it very consistently, and that is these DPUs, when we talk about, they come with, you know, different, you know, different capacity, right? So if you're talking about the bandwidth or the capacity of a DPU with 200 gig, then we should basically spell it out and say that, okay, here we are talking about the capacity of 200 gig DPU, and if that were to increase, the scale basically proportionally increases, right? So that needs to be talked about as well. Otherwise, it just basically, you know, confuses, you know, some of the people who probably are working on higher bandwidth or have lower bandwidth or whatever be the case, right?
But I think the bandwidth has not much to do, because there are flows that are extremely short. You know, there are cases that are flow of 2 packets. So the bandwidth typically is not a bottleneck. And I think the really stressful scenario is a 1 ENI scenario. The 1 ENI scenario is the one that basically forces the DPU to its maximum stress. The more ENI you have, the more it can optimize the speed. The single ENI is where it is a really stressful case.
So if you say single ENI, then you need to also say that, you know, how many ENIs per DPU we're talking about, and then that essentially automatically becomes
1 ENI per DPU. That is the scenario that is really difficult to support, because if you have multiple ENI per DPU, you can load balance among cores, among a bunch of things. But if you have only one, the load balancing becomes more difficult.
But the number of ENI will basically vary depending upon your capacity of the DPU that you have, right?
Yeah, but if I understand correctly, Microsoft is asking to support a case in which the DPU has one single ENI.
So I let me interject here that I think perhaps we can give some more clarity on what some ballpark figures might look like. And we can also talk about what capacity is and how you might hit capacity and where you're likely to hit capacity. I think there's a few things we can do here to clear this up. And we hear your feedback loud and clear, right? Like this needs more clarity. And so Michael, Christina, and I can work together and try and come up with a little bit more context here to guide folks, because like and this has been something that's been brought up from a few folks, is we need a little bit more clarity on what capacity should look like, what is a min bar, what is appropriate sizing, and I think we can get there together.
Yeah,
Okay.
thanks a lot,
Thanks.
James.
Thanks a lot,
Appreciate it.
Yeah. Another follow-up question that I have is we briefly discussed the connection tracking, so hardware flow learning. I assume eventually the controller need to know about all of this new flow. So what can you share? What is your thought process of how quickly those flow need to come to the controller? And for the short life flow, what is the expectation?
When you mean come to the controller, what do you mean by come to the controller? Because like in the controller, we don't really receive the flows.
Oh, so you're not interested from the controller. You're not interested in knowing the newly learned flow. But I thought we also briefly discussed there is a statistic associated with each of the flow. So
yeah, so the statistic is mostly from the point of view of not the flow, but more like counters. So for example, counters will be longer lived than the flows, right? Because counters will be pre-created before those. For example, like the counters, like the metering buckets. Let's say, for example, all the traffic. Let's say for the VNet, right? For this ENI, we'll be using these buckets, right? So every time when the new flow gets created and it gets some traffic, it increments this bucket, and the flows gets removed, the new flow gets created, or other flows gets created, also increment this bucket, right? So we want to basically, as long as ENI exists, right, those counters will exist. So we want to be able to basically query those counters' current value, right? But we are not interested to know really which, unless for the diagnosability or this kind of stuff, right? To debug some stuff, right? But we are not really interested in knowing that this counter was incremented by, like, what was the flow that incremented the counter, this kind of stuff, right? If the flow died or anything like this, right? So we just want to be able to query the current counter value.
So just to clarify, so now I heard you mention it's going to be a per ENI counter, and earlier we also talked about potentially per LPM entry flow per LPM entry counters.
No. So let me clarify on this. So basically, the counter is basically an object on which data is being counted, right?
Yes.
And basically, we basically will be creating there on our side per ENI, right? Whether we need to do an API call to say, hey, add this, for example, counter and associated with this ENI, or add this counter to a DSC. We can add this counter globally. That's not a problem, right? Yeah. The stuff is basically when later we are creating a route table, right, and route entry or the mapping, we should be able to basically reference the counter, right? So basically, and the reason why I said for the ENI, because we right now don't share the same counter across different ENIs, right? So there is this locality of this, right? So from the point of view is kind of, you guys can keep this counter as a global object, right? I'm just saying that we will not be referencing the same counter from two different ENIs.
Yeah, so let me rephrase my question, Michael. So from the controller point of view, you are not interested in per flow counter. Did I get that right?
Let me fully clarify. So from the controller point of view, right, I'm interested in the counter, which is, for example, set up on like counter as an object, which is set up, let's say, on DSC level or ENI level, that the flow should increment, and I'll be querying those counters. I'll not be querying flows to get the counter ID for the flows, right?
Okay. So you are not interested in per flow counter, and you are not interested in learning about the flow that hardware have learned in the flow table from the SDN controller point of view.
No, so basically, it is like this, that for example, there should be ability that each flow should increment some counter, right? Whether, for example, in this case, I will define that for example, because of the routing rule, I will plan, for example, lots of mappings, and each mapping will refer separate counter object, right? Then at the end, when the basically packet will come, and it will create lots of flows, and each flow will have separate counter, right? So in this case, each flow will have a counter, right? And potentially those flows can share the same counter, right? Or they can have the same, or they can have unique counters depending how the connections from the customer originates, right? But I will not be querying flows to get the current counter value. There is a like not for the metering, right? There is a separate discussion that we even are not starting here, right? Which is kind of diagnosability. So basically, customers sometimes wants to have ability to basically do proactive, let's say, dump the current flows which are active, right? Which doesn't have to be fast, and of course we'll be missing flow. It's kind of like sampling, right? Of course we will not be missing all the flows, so it's not tracking all the flows, but they have ability to, for example, okay, let's sample at basically like to get the current like flows that are established, because they just want to know what kind of connections are happening right now through their VMs, right? But it's a completely separate topic. It's more about at some point, because you guys anyway will have in the hardware the flows, right? Be able to give it as API to kind of query this. It doesn't have to be fully consistent. It just gives the return current state, this kind of stuff from this point of view, right? But we'll not be using this method for let's say metering customer or anything like this, right? We'll be just querying the specific counters, right? So let's say we create, let's say 100 counters, right? Unique counters. One will be saying like this counts VNet traffic inbound, this and separate like for outbound, and this counts, for example, VNet peering traffic. This counter will count traffic for this IP. This count traffic will, for example, for this IP. This counter will count basically internet traffic, this kind of stuff, and then we'll associate those counters in specific routing rules, right? And then as the flows gets propagated, the flow, when it gets created, will refer to those counters and will increment those kind of counters. The flow will die, new flow will arrive, or those kind of stuff, right? With specific stuff, right? And from the control plane, I will be only, for example, let's say every 10 seconds, right? Saying, okay, that 100 counters that I created before, right? Give me the current values of those 100 counters.
Yeah. So basically, Michael, from the SDN controller. Sorry.
Yeah. So Michael, just a follow-up question on your thing. It looks like the counters will live long after the flow has gone away.
That's correct.
So then, in that case, I guess we will need to know how many counters of the scale, because if you're talking about 50 million flows as a scale that is requirement, how many counters we are talking about beyond that? Because unless basically it is read and being basically go ahead and I guess destroyed, that counter essentially need to be preserved by the hardware even after the flow is gone. So I think those, along with everything else that I said earlier in the meeting, the counters is a massive subject that we need to really talk about, especially with all the statistics and per flow notification, per flow statistics, these global counter objects and their associations with all the different ways we want to really handle it. How often we're going to read it, what type of APIs are going to be, whether we are going to pull or push from the controller, all of those things. I guess we need, probably I will request that we dedicate, perhaps maybe the next meeting or something to discuss that. So
you are requesting to the next meeting so we can discuss this, and we can discuss those limits and this kind of stuff, right?
Right.
Yeah, definitely. And I can tell you right now the ballpark, right? The ballpark is right now, for example, usually I believe like max that we were thinking of is like, let's say, I think at least right now that we are using is like 10K per ENI from the counters, right? And on average, we are using much less, right? So, but this is what basically some deployments basically supports right now, kind of like a 10K unique counters on some ENIs, because just like some customers also want to have some specific metering traffic for specific stuff, right? So
you guys,
that's the current thought.
I'm super late to my next meeting.
Yeah, we should.
Does anyone else have a 10?
Yeah, we should probably follow up on the next meeting, right? Take all the AIs, and especially the main AI I understand that is the scale to get those numbers with potential, those kind of like multiplications there.
Yeah. And if you can throw your comments and issues into the GitHub, we would appreciate it. And yes, we will work on scale and everything and get back. Thank you, everyone.
And then I would also say that, for example, if you guys have some specific format, if you guys also would like to see this data that you guys believe will be the most readable from your guys, right? Feel free to send us an email or send an email to the community that, hey, you guys are, for example, tracking the current like something similar in this format or this format, right? And we will try to basically see maybe you can also like fit in this format with regards to this. Otherwise, basically, we'll just continue use the current format that we have, right? So if you guys have some way that you would like these numbers to be expressed, then we can also think about this. Cool, awesome.
Sure.
All right, thank you,
Thanks
everyone.
a lot, Michael and Christina.
Yeah.
Awesome.
Yeah.
Thanks, guys.
Thank you.
Have a good one.
Okay, bye-bye.
Bye-bye.